In these videos, I aim to go through theory and solve multiple varied questions in the shortest time possible. Using these methods, I've got students into top schools and universities. If that's something that sounds interesting to you, please take a moment to subscribe. So let's look at scaling down first. Now, these methods are aimed to help you and save your time. So let's start with this data set here. Now, as we've discussed before, to get the mean, we have to add all of the values together and divide by the number of them. In this case, there are 9 values. Now, it's going to take us quite some time to type in 245 plus 243 plus 244, etc. But you might notice that every value is 200 and something. So if we subtract 200 from every value, we get these values. And it's quicker to type in 45 plus 43 plus 44, etc., etc. But you can also notice that every value there has a 40 in front of it. Therefore, if we subtract 40, we end up with 5, 3, 4, 9, 8, 5, 1, 7, and 3. So now it's very quick to work out the mean because we can add all of those values together, divide by 9, so that's 45 divided by 9, which equals 5. However, now we have the mean of those values. To get the mean of our original data set, we have to reverse what we've done. We subtracted 240, so now we have to add 240. So our mean is actually 5 plus 240, which is 245. So if we have this data set next, do you know what number we would need to subtract to make our calculation easier? Now, we can't use 390, unfortunately, because some of our values in the data set are under 390. So how about 380? Well, if we subtract 380 from every value, we end up with 16, 12, 19, 9, 10, 2, 11, and 17. So that is going to work. So our mean is all of those values added together, which is 96, divided by 8, because we have 8 values, which is equal to 12. And then, of course, we then have to reverse what we've already done. So we have to add 380 back to 12, and that gives us 392. So next, let's talk about linear transformation. And this is used when the numbers are a bit more complicated. For instance, in this data set below, all of these numbers here are decimal fractions. So in this case, it would be much easier, and we're less likely to make a mistake, if all the numbers are above 0, if we can move the decimal point in each number. Well, if we multiply every number by 100,000, then we get 156, 153, 158, etc. But you may have already noticed that now we have these numbers, we can also scale down because every number is 150 something. So if we subtract 150 from every number, we end up with 6, 3, 8, 7, 5, 4, 2. Perfect. So now it's easy to calculate the mean. Add all those numbers together, divide by 7, and we end up with 5. However, this time we have to reverse 2 separate steps. With that 5, first of all, we have to add 150 back, so we get 155. And then, because the first thing we did was multiplied by 100,000, we have to divide by 100,000. So that's 155 divided by 100,000. So our answer is 0.00155. So a quick final example. Do you know what to do if we have a data set like this below? Well, similarly to before, all these numbers are decimal fractions. So we're going to multiply every number by 100,000. So we get 354, 358, etc. Then we're going to subtract 340, which gives us 14, 18, 15, 9, 1, and 3. Then to find the mean, we're going to add all those values together, which gives us 60, divide by 6, because there are 6 values. That's equal to 10. And then to get the mean for the original data set, we have to reverse what we've done. So we add 340 to 10, which gives us 350, and then we divide by 100,000, which gives us 0.0035. That's it for this video. Thanks ever so much for watching. If you did get some value out of it, I'd really appreciate it if you could hit that like button and subscribe for more videos like this. See you on the next one.